Assalamualaikum and a very good day everyone. We are from group 2 from BMMD 1-2 and today we are going to present about our mini project for our subject computer aided manufacturing for this semester. Okay, without further ado, let's start. So for this semester, we were assigned the task of selecting a product part from any automobile parts. We have chosen the ignition cover for our automotive parts in this project. Hence, we showcase how to design the ignition cover using SolidWorks software. We must map out approach and the optional method in 3D modeling, machining, and toolpath while in attempt to manufacture ignition cover. So a little information about our product. So to be specific, we are going to use KTM Duke 390 model 2014 for our model. So the initial cover was designed for KTM 390 Duke and RC Duke, and it is manufactured by Bajaj Auto and KTM Motor Manufacturing Incorporated, in which for the Asian region it is mainly manufactured in Philippines. So the objective for our project are: first, we have to design the product using SolidWorks or any CAM modeling technique. Second, we have to plan machining strategies and toolpath methods. Third, we have to apply the procedure of CAD/CAM programming using the CAM software. And the fourth, we will simulate the machining operation prior to the machining. And fifth, we have to generate NC code for the part programming.
I will explain about solid model. From the left side is the actual product, which is KTM ignition cover. In this course, we will turn the product to the inverse engineering product, and it will look like exactly on the right picture. And now for the part modeling process. These are the process involved to form a product called ignition cover. There were various types of process such as extrude cut, chamfer, fillet, and hole. All of these are being used by using a SolidWorks software. In the part of drawing, we had choose to use the third angle projection view for both drawing. The first one is the detail drawing, which is the drawing that we get for the model. The second one is for the assembly drawing. By using a DelCam software, these are drawings that be combined with the stock size and the size of the model. Of course, we must transfer the NC code that we get from the DelCam to the CNC machine. These are type of machine that we choose to perform our machining process. Together, we include the model and the detail of the machine. This model are called the MC635 vertical Ecoline, manufactured in Germany on 2008, and it also can be working in 3 axes. For the post control, Siemens S840D console are being used to control the process of the CNC machine.
So this is a table of process planning. From here we can see the operation list that we get after running a simulation, and then this is a calculation for cutting speed for the facing, surface, cut and groove. And then we can see here this is a machining process step for our project. The first one is surface, facing, feature and groove. So we can see right here we have tools and size table. For the left side we using a face mill and a flat end mill and ball end mills, and for the right side of the table we put the size of the tools and materials.
For this section, we are going to demonstrate the simulation for centerline and 3D simulation.
Based on the table shown, we are able to verify the NC codes generated from our solid modeling. As a summarization from the whole process of our solid modeling, the process of our solid modeling is not complex at all, only by using a few features such as boss extrude, extrude cut, and chamfer. The technique used for the detailed drawing of our project is a third angle view and scale of 1:1, an assembling drawing with stock size of 100 x 120 x 47. Hence, we have chosen CNC and milling machine DMC635V Ecoline to operate machining process because our product only use 3 axes, which are X, Y, and Z. Furthermore, the operation for our process planning is very simple, with the use of facing feature to level the top part of the model. Then we use surface feature for roughing and finishing process. Afterwards, to create the circle shape at the top of the model, we use cut feature. Lastly, grooving feature is used to create the racing KTM font. From the process above, we produce calculation for cutting speed based on the formula given for each feature. Meanwhile, to obtain the theoretical calculation, we use the spindle speed data based on the given formula. The tool we have used for the whole process are flat end mill, face end mill, and ball end mill. For roughing process, we use multiple rough with diameter of 20 and 14. To achieve a good and clean finishing, we use step over rapid distance of 0.3 mm and Z increment of 0.4 mm. Next, we have changed the plant feed override to 125. Thus, we run the centerline simulation and 3D simulation to observe the outcome of our solid modeling and check if the process and result are correct. Moreover, NC codes are generated and verified. Finally, from the beginning and towards the end of this mini project, there aren't any complications, as well as we managed to reduce the time to finish this mini project. From this project, we can conclude that there are many steps involved to produce a better quality product without any defect or overshoot problems. This project has proved how it has undergone from designing through computer software, which is Delcam for SolidWorks 2019, through the machining process. The KTM ignition cover being designed by using solid modeling based on what we have learned throughout this project. Some features are applied in this design to make it seem more realistic as the real ignition cover, so we are able to improve our designing skill throughout this project and learn from our mistakes. Thus, the procedure of CAD/CAM programming also has been implemented by using Delcam software. The design can be simulated based on the features that has been applied in the software. Throughout this project, we have learned on how to generate the NC code by using the Delcam software and verify the code to the file that can be accepted by the CNC machines. It is a crucial part because the program of the machine will give the command out to the machine based on the code that has been verified correctly. We also have learned on how to handle the 3-axis CNC milling machine at UTEM facility to run the milling machine process on the raw material that has been given. We can get the exact shape of the product based on what we have designed previously.